Alright, so here I'm going to go through a few examples of how you multiply 3 or more polynomials together. Now in these examples I'll just be multiplying 3, but you're going to use the same idea if you need to multiply 4, 5, or 6. So, first thing you want to do is basically, you know how to multiply 2 together. Alright, so what we're going to do is we're going to use that and that only. So what we're going to do is we're just going to focus on these two first. And we're going to say, okay, I know what that's equal to. And then whatever we find, we'll multiply the last one on there at the end. So I'm going to do the box here. I would have x plus 3, and I would have an x plus 1. Okay, so we fill this in. We get x squared, we get 3x, we get x, we get 3. So when we multiply these together, what we get is we get x squared plus 4x plus 3. Okay, so why is it not dotted? There we go. So what I have is this x plus 3. This x plus 3 times x plus 1 is really just this. Okay, so what I'm going to do is I'm going to take these two, and instead of writing them out like this, I'm going to multiply them together and write them like this. So really now what I have is I just have this polynomial times this polynomial. Okay, and now again I have two things that need multiplied together, and then once I do this, that would be my final answer. So let me shrink this a little bit. Alright, and now I'm going to do my box for this multiplication. Okay, so on the top here I have x squared, a 4x, and a 3, and over here I have an x minus 2. Alright, then I would just go through and fill out my box by doing the multiplication. So x squared times x is x to the third. This is a 4x squared. This is a 3x. Here we have a negative 2x squared, and here we have a negative 8x, and here we have a negative 6. And my final answer, I would just write this. I would just combine my like terms together. Again, like terms must have the same powers, so I'm going to go ahead and shade these. This here is my x squared. This is an x squared. This is the linear term, which has an x, and this is a linear term as well. So the reds are actually called quadratic terms because they have a second power. The blue ones here that I highlighted are called linear terms because they have just a power of 1. And then we write our final answer. We would just combine our like terms. So I'm going to write these in descending order, which means from highest power to lowest power. So my highest power is x to the third. It doesn't have any like terms, so that's all I need. My next highest power would be an x squared, so I would combine my 4 and my negative 2 together. That's a positive 2. My next highest power is just a 1. That's the linear terms. We'd combine 3 and negative 8 together to get negative 5x. And then my negative 6 does not have a like term, so that would be my final answer. So if you see, we're really just multiplying two things together at any given time. We're not actually trying to multiply all three at the same time. We're just taking it in steps. Now you could have done that in any order. So if you would rather have taken these last two and multiplied them together first, and then taken that result and multiplied by the first one, that's fine as well. And that's fine because of the commutative property. Commutative property of multiplication just says that I can reorder the way I multiply things and I should still get the same answer. So let's do another example here. Here's one. Looks a little different. But please be careful here. You do not want to say that this is x to the third minus 2 to the third. No, no, no. Okay? And why is that? Because this is subtraction. Okay? We can only basically distribute this 3 in here when we have multiplication in the middle. Okay? We have subtraction and addition, that kind of messes things up for us. So again, we're not distributing that 3 in unless we see a multiplication symbol in the middle. Okay, so if that was x times negative 2, so if this was like negative 2x to the third, then we can say that that's negative 2 to the third times x to the third. See, that's multiplication in there. This is subtraction, so it's different. So what you want to do is you want to write this out to what you know it means. So we need to know, what does the power of 3 mean? The power of 3 means I take the thing in the parentheses and I multiply it 3 times. So this is x minus 2, x minus 2, x minus 2. All right? And then what we're going to do is just kind of what we did on the last slide. We're going to take these, multiply them together, and then once I find my result there, I'll multiply it by x minus 2. So I would do a box. I would have x negative 2, x negative 2, and then I'd fill in my box. So I have an x squared, I have negative 2x, negative 2x, and our negative times negative is a positive 4. So this really becomes x squared minus 4x plus 4. And then again, I'm going to bring this down, and we'll multiply this one on there last. All right? So all I did again was I took these two, this x minus 2 times x minus 2, and I did the multiplication, and I figured out that's actually the same thing as this. Okay, so really I took these two and I simplified them down to here, but I still have my extra x minus 2 to multiply by, so that's my next step, is to multiply that on there. Okay, and I will go ahead and do a box. So I have an x squared minus 4x plus 4, and I have an x minus 2. So I'll go ahead and fill in my box. This is a base to a base, so we add powers. Okay, x squared times negative 2 is negative 2x squared. Negative 4 times negative 4 is positive 8. And negative 2 times 4 is negative 8. Alright, I'm going to go through here and highlight my like terms. Again, like terms are you have to have the same power on your variable. So these are x squareds, these are x squareds, these are x's, and these are x's. And we have no other things to combine with my x to the third up here. Nothing else to combine there, and we have nothing else to combine here, so they're just going to kind of follow down into our final answer. And again, we always like to write our answer in descending form, which is also the same thing as standard form for a polynomial, which means from highest power to lowest power. So my highest power is my x to the third, so I'm writing that first. My next highest power is an x squared, so I will be combining my reds together there, and I have a negative 2 plus negative 4 is a negative 6x squared. Next thing I'll do is combine my linear terms, so I would combine 4 and 8 together to get 12. And then again, this negative 8 will just tack along to the end because it has no like terms. So that would be my final answer for that one. One more, all right? Again, we can choose, I'll do it a different way this time. I'll take the second two here. I'll multiply them together first, and then I'll multiply this 4x plus 1. That's supposed to be an x. Sorry, it looks bad. I'll multiply that 4x plus 1 last. So I'll do these two, I'll multiply them down, I'll get some answer for the multiplication, and then I'll take that result and I'll multiply by my first one, and then I will have multiplied all three together. So here, again, box method, 2 by 2 box, because we have each thing has two terms. Okay, so we get 3x squared, we get a 3x, we get a negative 4x, and we get a negative 4. So this is really 3x squared. Then we combine our linear terms together to get a negative x. And the negative 4 hangs out there because it has no other like terms. Now, we will bring this down. Okay, so now it's really just a new problem. So up here, what we started with, this up here and this down here, same thing. All right, it's the same problem. It's no different. The only difference is that this here we multiplied together and we just rewrote it like this. Okay, so now we have one more step to do, is to multiply these together. And what we're going to have is we're going to have a 2 by 3. Because, again, we have two terms and three terms in our polynomials. This one has two terms, this one has three terms. So we would copy these up here, and we'd copy this one here. Do our multiplication. 3 times 4 is 12, and then x squared times x is x to the third. Negative 1 times 4 is negative 4. X times x is x squared. Negative 16x. 3x squared. Negative x. Negative 4. Then we're going to combine like terms here. So we will look here at the x squareds. They are like terms, and then our linear terms here, our x's, they are like terms. All right, final step. Write them in descending order, which means start with your highest power first. Our highest power is the x to the third, so I'll write that term first. Next highest power is the x squareds, which are called the quadratic terms. We'll combine those together. A negative 4 plus 3 is negative 1 x squared. Combine our linear terms together. Negative 16 plus negative 1 is negative 17x. And then our negative 4 was not a like term. It just stays along for the ride to the final answer. And that is it.